Welcome to today's class Ace Math with Joy. So today we're going to be looking at game theory. So now there's this popular game that is trending on social media. The one they say rock, paper, scissors. I don't know if you've seen it. Now, if you have participated in that game, how you know the rule of the game, or if you have seen people who play that game, you will see that as you are playing, you are thinking of what your opponent in such games you think, right? Now, whatever I do, I should know that whatever I get will affect the other opponent, or whatever the opponent gets will affect me, either in the good way or you know that. Okay, so now what is game theory? So imagine a friend, let's say Ada and Bola, they are playing a game, right? Now, each person has a choice to make. Okay, so in games, you have a choice to make. So that what or card games you play, you are checking. What do I play now? What do I play now? Let me check my game. All right. So you are calculating what to do because you know that whatever you do affects your opponent. Okay. So now each person has choices to make. So what Ada gets may depend on what Bola chooses. And then what Bola gets may also depend on what Ada chooses. So that's basically what game theory is all about. So game theory is just the study of how people or players make decisions, how people or players make decisions when the results depend on the decision of others. Okay, so how people or players make decisions when the results depend on the decision of others. So let's look at this example. We're talking about Ada and Bola. So let's maintain the Ada and Bola so that you will understand what we're talking about. So now look at these two friends. Let's say these two guys are selling ice cream. So now what are they to choose from? So either they choose high price or they choose low price. But whichever decision they make, they know that the results depend on decision of the other person, right? Now, how does that work? So now each of them can choose high price or low price. So if both of them should charge that high price, what will happen? They will both make profit, is it not? Good. But if Ada decides to charge low price, not knowing what Bola has in mind, in a game, you don't tell somebody, look at what I'm going to do. Is it not true? Ehen. So now, if Ada charges low price, why Bola is charging high? What do you think happens? Ada charging low price will make her attract more customers. Is it not true? Ehen. So now, attracting more customers, so Ada has to think, what will Bola do? And Bola also has to think, what will Ada do? So that is game theory. Now, there are key words you need to know in this game theory before we look at examples. The first is player. You have the player. So now, a player is a person, a company or group making the decision. So in this case, Ada and Bola are the players. Then the next keyword you need to take note of is strategy. That's the strategy. So now the third keyword you need to get familiar with is the payoff. The payoff. Now that's the result or reward obtained after the players make their choice. So what do you get by making your choice? So if both of them decide to sell at high price, they make profits. If Ada decides to reduce her price, what happens? She attracts more customers. So that is the payoff. All right. So now to obtain this payoff, we have the next keyword, which is the payoff metrics. So before you can be able to understand this topic, you must have understood metrics. So we have the payoff metrics. All right. So now this is just a table showing the possible outcomes of each player's or the player's choices, right? Okay, so now let's have an example. We have two persons here. We have two players here. We have Ada and we have Bola, right? Okay, Bola, that's Bola. All right, now what are the strategies? We have the high price. So let's say we have Ada high price, the same Ada, low price. If she decides to sell at a lower price, then let's say we have Bola selling at high price and then Bola selling at low price. Okay, so now if two of them decides to sell at high price, so this is the payoff. What happens? So the first, in how we read this payoff metrics is column, that's Ada before Bola. Okay, so we have if Bola sells at high price when Ada is selling at low price, look at what happens. So who is gaining more? Who is getting more points? Then if Ada is selling at high price when Bola is selling at low price, look at what happens. So Ada gets 1, Bola gets 6. And then if both of them sell at low price, you see that the payoff is the same for both of them, but not a big profit, just like in the case where both of them sell at high profit. So remember I said the first number belongs to Ada while the second belongs to Bola. So using the first payoff value there, which is 4,4, what it means is that Ada gets 4, Bola gets 4. Now, the next thing we need to know is how do we read a payoff metrics? It's very important for WAEC. So now, suppose Ada, let's assume Ada chooses high, and Bola chooses low. What do you think will happen? If Ada chooses high and Bola chooses low, this is the outcome. That is 1,6. It means Ada gets 1, while Bola gets 6. All right. So if you can read the payoff metrics, I think that's you're good to go. So what's the next important thing to know is what a zero-sum game mean. Zero-sum game. What does it mean? Now we get to a very important type of game. So this type of game is when one player's gain is exactly the same player's loss, right? Okay, so but in this payoff metrics we have here, there is no zero-sum game. Why? Because both of them are gaining at the same time. Okay, so but in that zero-sum game, we have, so assuming we have a payoff metrics this way. Okay, let's say Ada. Okay, so just let me just have X here, Y here. Let's say Bola. Let's say U here. And then let's say K here. Okay, so if we have 3 here, for instance, and then -2 here, -1 here, and then 4 here. You see how this one is now, right? Okay, so if you look at this matrix, you will see that it's different from the first one. That first one, two persons are gaining at the same time. Ada has this. At that point, Ada has something, Bola also has something. Do you see that? But now, looking at this type of matrix, which is called a zero-sum game, you will see that in the first entry in this matrix is 3. That 3 there means that if Ada gets 3, it means Bola will get -3. All right. So if you now sum Ada's gain and Bola's gain, it will be 0. Then having -2, if Ada has -2, it means Bola will have 2. So summing what Ada and Bola has, it will give you 0. So the next entry -1 means if Ada has -1, Bola will have 1. Sum there again, 0. The last one, if Ada has 4, Bola will have -4. So in a matrix or in a payoff matrix, when you have single entry, just like this, that is when we talk about a zero-sum game, such that when you add what two of them get, it will give you 0. Quite different from what we had earlier. Then the next important thing we need to know is the max min and min max. That's the two important strategies in this game theory. Before we start looking at WAEC standard questions, we have the maximin and then we have the what? The mini max, right? Okay, so now this maximin, imagine you are playing a game and you want to make sure you don't get a terrible result. Hmm? So let's pick the first word, the first strategy, which is maximin. Now, what this maximin means is list your minimum, list the minimum strategies, and then pick the maximum out of the minimum. That is maximum of the minimums. Maximum of the minimums. So now player A is asking, if things go badly for me, what's the worst, I could get from each strategy? So the A can decide to choose best among those worst outcomes. And that will lead us towards the mini max. So mini max is simply saying, choose the minimum of the maximums. So the next question is, how do we do that? Because if you don't know how to do that, when we start solving questions, it will be a problem. How do we do that? How do we choose maximum from the minimums, and how do we choose minimums from the maximum? Okay, now to find maximum, or remember we have two players, A and B, all right? So now if A chooses the best among the worst outcomes, like we said, you find the minimum in each row. So for A player, remember that are you seeing where player A is and where player B is? So to find the maximin, this we can understand. So for the maximin, go through the row. For instance, look at the matrix we have here. So let's look at the row. So we have 3, -2, for instance. We have 3, -2. So now in this 3, -2, we have -2 as the minimum. Then we go to the second row, we have -1, 4. Now this -1, 4, what is the minimum there? We have -4, right? So we said for the maximin, yes, we pick the maximum of the minimums. And then we say we do that row wise, right? So when we pick the entries in the row or the strategies in the row, pick out the minimum, keep it by the side. Go to the next row, pick the minimum, keep it by the side. Then when you are done writing out the minimums, like this, we have -2 and -1. Which of them is the maximum? And that is what? -2, -1 rather. -1 is the maximum. That is maximum. Then maximin. Then if you have minimax, minimax is column wise. So if you go column wise, you have 3 -1 and the maximum there is 3. Then in the next column, we have -2 and 4, and then the maximum is 4. So we have 3, 4. What is the minimum there? That is 3. So that is how we pick the maximin and then the mini max. So let's look at this question together. Question there says you should find the maximin. The next question, the minimax, and then determine whether the game has a saddle point. So if you can answer the A, B, and C part of these questions comfortably, NECO, this is a one topic that NECO loves so much, this game theory. Okay, now let's go. So what do we do to find the minimax? Remember we said minimax is row wise. Okay, the first is maximin. All right, so to determine the maximin, we go row wise. Solution. So we are to find the maximin. So how do we call a matrix? We call a matrix row by column, not column by row, right? Okay. So what kind of matrix is this? This is a 3 by 3 matrix, right? So to find the maximin, we go row wise. So going row wise, we have 4, 2, 6, 4, 2, 6. And then the minimum in these entries is 2. So going to the second row, we have 3, 5, 1. And then the minimum is 1. And then going to the third row, we have 2, 4, 3. And then the minimum there is 2. Okay, so we have 2, 1, 2. We have 2, 1, 2. So this is the minimums in this game. So maximin is saying we should pick the maximum rather out of these minimums. So what is the maximum? The maximum is equal to 2. That is the biggest, the largest out of the minimums. So the maximum is 2. Then coming to minimax, we go column wise. Coming to minimax. So going column wise, in the first column, that is our B1. In B1, we have 4, 3, 2. 4, 3, 2. So what's the um, maximum? The maximum we have is 4. And then in the next column, that's B2, what do we have? We have 2, 4, 5. We have 2, 4, 5. Okay, so what is the maximum? The maximum is 5. And then in the third column, we have 6, 1, 3. 6, 1, 3 with a maximum of 6. So the maximum strategies we have here, we have 4, 5, 6. So the minimum in these maximum strategies, the least is 4. So our minimax is equal to 4. So the next question says we should find the saddle point, right? So we have a maximin of 2, and then we have a minimax of 4. Unfortunately, they are not the same. So saddle point, when minimax is equal to maximin, there is a saddle point. So our maximin is 2 and it is not equal to our minimax, which is 4. So it is when they are equal rather, that we have a saddle point. So at this point where minimax is not equal to maximin, our answer for the third question will be that there is no saddle point. So I want you to look for more questions on this topic. Please solve and then let me know if you have any challenge. See you in the next video. Bye.